So I'm going to need a calculator here. So let me do this. That. Here we go. There we are. Okay. So we need to identify the percent change as an increase or decrease, and then find the percent of change. So to do that, we've got 50 pounds, and 50 pounds is going to go down to 35 pounds. So that would be a decrease. And then we know that we've got to keep our numerator positive, so we'll go 50 minus 35 divided by 50. So 50 minus 35 is 15. And 15 divided by 50 is 0.3. That's a decimal, so we're going to take that decimal and multiply it by 100. And so we get 30% as a decrease. We're going from 10 gallons to 24 gallons. That's an increase. So that's 24 minus 10 to keep the numerator positive over 10. So that's 14 divided by 10. So that's 1.4. This is a decimal that we're going to multiply by 100. So that gives us 140% increase. Next one, we're going from 16 centimeters to 44.2 centimeters. That's an increase. So 44.2 minus 16 divided by 44.2. Not 44.2. What am I doing? No, silly Manchester. We started at 16. So 44.2 minus 16 gives us 28.2 over 16. We divide by 16 and we get 1.7625. That's a decimal, so we multiply it by 100 to find that we have a 176.25% increase. It's an increase to go from 3/8 to 7/8. And so we go 7/8 minus 3/8 divided by 3/8. So that's 4/8 divided by 3/8. And that's keep, change, flip, or multiply by the reciprocal. So that's 4/3. And 4/3, 4 divided by 3 is 1.3 repeating. So I'm going to go out 1.333. That's a decimal, so we're going to multiply by 100, and that gives us 133 and a third % increase. Number 5, going from 5/4 to 3/8. Well, hopefully you realize that this is improper right here, that 5/4. And because that's improper, it's got to be bigger than 3/8. So we're going to be doing a decrease then. 3/8, well, 5/4 minus 3/8 divided by 5/4. We need a common denominator of 8 here, so that becomes a 10 on top. So this becomes 7/8 over 5/4. Keep, change, and flip, better known as multiply by the reciprocal. So this becomes a 1, this becomes a 2. 7 times 1 is 7. 2 times 5 is 10. As a decimal, this becomes 0.7. Since this is decimal, we want it as a percent, so we multiply by 100, and we find that this is a 70% decrease. Over here, we want to know if our friend is correct. They're going from 18 to 26, and our friend is not correct because our friend used 26 as the original. This 26 should be 18. A researcher estimates that a fossil is 3,200 years old. Using carbon-14 dating, a procedure used to determine the age of an object, the researcher discovers that the fossil is 3,600 years old. Find the percent of error. So the error, the actual amount was 3,600. The error is going to be 3,600 minus 3,200. So that's 400. And then we want percentage of error, and that's 400 divided by 3,600. So 400 divided by 3,600 gives us 0.1 repeating, which I'm going to write out as 0.0111 repeating, because I'm going to multiply that by 100. And that gives me 11.1 repeating percent error. Now, what estimate gives the same percent error? Well, 400, we got this 400 from being short that many years. So we could just add 400 to 3,600. Because, so what I'd say is, the amount of error would be the same at 4,000 years old, and thus so would the percent error. Explain why the change of 20 to 40 is 100% increase, but a change from 40 to 20 is a 50% increase. The reason why, and I'll show this to you, we'd go 40 minus 20 divided by 20, or we'd go 40 minus 20 divided by 40. And so you can see that the difference is the denominator. The difference is we are dividing by different denominators. Okay, table shows the population data for our community. What's the percentage change from 2011 to 2017? So this is our original. This is our new. And so we're looking at 13800 minus 11800. That keeps us positive. Our original is 11,800. 13,800 minus 11,800 is 2,000. So we're going to divide that by 11,800. So 2,000 divided by 11,800. That gives us this wacky number. We're going to round that to 3 decimal places, so that's 0.169. Multiply that by 100. That gives us 16.9%, and that is an increase. Now, it says predict the population in 2023 and explain your reasoning. So what they want you to think this through here is that there's 2 possible decent answers. Someone might say, hey, we increased by 2,000 from going from 11,000, or sorry, I biffed on the decimal points. Oddly enough, it doesn't change the answer. I'm sorry about that. I'm not going to go back and redo this problem because of it. But I biffed on the decimals, or the number of places. I'm sorry about that. End of the school day, that kind of jazz. But some would say just add 20,000 to this number here. But that's another reason why percent of increase is so much better, is if we find the percent of increase and apply it to 138,000, then we might actually get a better guess. So we're going to go, we know that we started with 100%. We're going to add to that 16.9%, giving us 169%. And we want to know what is 100, or sorry, not 100, 116.9. What is 116.9% of 138,000? So here we go. I'm going to use the equation method. So A equals 1.169 times 138,000. And so my prediction for the population, if it grew by the same percent times 138, my prediction would be 161,322 people. And that's just, again, it's an estimate. It could very well be wrong, but I've got a reason to back it up. I'm just saying, hey, maybe the population increases by 16%, 16.9% in that gap of 6 years all the time. So that's my best guess. Suppose the length and the width of the sandbox are doubled. Find the percent change of the perimeter. So at first, the first perimeter, without it changing, is 6 plus 6 plus 10 plus 10, which is 32 feet. If we double the perimeter, that's 12 plus 12 plus 20 plus 20, which is 64 feet. So then to find the percent change, it's 64 minus 32 divided by 32, which gives us 32 divided by 32, which is 1. Remember, this number is a decimal, so we multiply it by 100, and we get that there's a 100% increase in perimeter. However, the percent change of area, well, at first it's 6 times 10, which is 60. But if we double the length and width, that gives us 12 times 20, which is 240. So now we're looking at 240 minus 60 over 60. 240 minus 60 is 180 over 60. And so that gives us 3. But that's a decimal, so we multiply that by 100. And so what we see is that we have a 300% increase. So I'm going to say it this way just because I want those of you watching this to, maybe you're curious. The 100% means that we've doubled the perimeter. The 300% means that we've quadrupled the perimeter. All right. A company fills boxes with about 21 ounces of cereal. The acceptable percent error is 2.5%. So we want to stay below 2.5%. And box A contains 20 ounces and box B contains 20.4 ounces. Box B contains 21.5 ounces. Tell whether the box is an acceptable weight. Okay, so here we go. 21 minus 20.4. That gives me an error of 0.6 ounces. So we take 0.6 divided by 21, and 0.6 divided by 21 gives me this mess, which is 0.029 times by 100. That's 2.9%. That's greater, so the first box is unacceptable. Unacceptable. The second box is 2.15 minus 21, which gives us an error of 0.5. So we take 0.5 divided by 21, and 0.5 divided by 21 is 0.024. That's a decimal, so we multiply it by 100. That gives us 2.4%. That is acceptable. All right, number 12. A number increases by 10% and then decreases by 10%. What will the result be greater than, less than, or equal to the original number? Let's find out. We're going to start by taking the number, and we'd have 110% of that number. So that would mean that we actually have 1.10 times some number. But then we're going to decrease this value by 10%. So what that means is that we're actually, if we start off at 100% and we decrease that by 10%, that means we're at 90%. So we now want 90% of 1.10. And if we look, 90%, that'd be 0.9 times 1.10 n, which would give you, my brain just fogged up, sorry, 0.9 times 1.1 gives us 0.99 n. This, I'm going to unfortunately write this all the way over here, 0.99 n is less than n, the original number. So therefore, this would be less. You want to reduce your daily calorie consumption by about 9%. You currently consume about 2,100 calories per day. Use mental math to estimate the number of calories you should consume in 1 week to meet your goal. Okay, so you want to take this 2,100 and you want to reduce your calorie consumption by about 9%. So what we're going to do, and I'm going to write things down, although it says mental math, I'm just not going to use a calculator. So first things first, I'm going to change the 9% to a 10% because I can work with 10% easier. And then I'll change the 2,100 to just 2,000 because I can work with that easier. And what I recognize is that I want to reduce by 10%. So 10% of 2,000 is 200. So I want to take off 200 calories from my normal consumption every day, which means that I'm looking at around 1,800 calories per day. And I want to find out about how many calories I should eat during a week. So there's 7 days in a week. So we take 18 times 7, 006, carry the 5. So we're looking at calories per week. So 12,600 calories per week. It's a rough estimate. There's other estimates. There are better estimates, but this is an estimate. So donations to an annual fundraiser are 15% greater than this year than last year. Last year, donations were 10% greater than the year before. The amount raised this year is $10,120. How much was raised 2 years ago? Okay, so donations are 15% greater this year than last year. So last year we had 100% of whatever we had. We added 15% to it, and now we have 115%. And so we know that 115% of last year is 10,120. So that means we're looking at 1.15 W equals 10,120. We solve this by dividing, which gives us 10,120. Oh, whoops. I think I didn't make a mistake. There we go. So we get 8,800. Now that was last year. We now want the year before that. So this 8,800 is 110, because we're 10% greater, 110% of 2 years before. So we're going to do this again. We're going to go 8,000 800 is 1.1 W. So we divide both sides by 1.1. So 8,800 divided by 1.1 gives us $8,000 was raised in the fundraiser 2 years ago. 40 students are in the science club. Of those, 45% are girls. The percent increases to 56% after more girls join the club. How many more girls join? So we know that originally there's 40 girls in the science club and 45% are girls. Let's find out how many girls are in the club. So we've got, we don't know the number of girls. We'll call it the part over 40 is 45% of the whole. Cross multiply. It's 100A equals, and we need 45 times 40, which gives us 1,800. Divide by 100. And A is 18 girls. So now, what we're going to do is we're going to add some number of girls, and we're going to add some number of girls. And when we do that, we have 56%. So now we're going to cross multiply. So we're doing 100 times 18 plus x equals 56 times 40 plus x. So that's 1,800 plus 100x equals, and then 56 times 40 is 2,240 plus 56x. We're going to subtract 56 from both sides. Um, 100 minus 56 gives us 44, so we have 1,800 plus 44x equals 2,240. Subtract 1,800, subtract 1,800. So 44x equals 2,240 minus 1,800, 440. Dividing both sides by 44, x would equal 10. So 10 girls joined the group. So, write and solve an equation to answer the following questions. So, what number percent whole? So, A equals 0.25 times 64. 0.25 times 64, which is 16. A, P, W, so we're looking at 39.2 equals P over 100 times 112. Oh, I'm going to show you a shortcut here. 39.2 equals, if I divide 112 by 10, that gives me 112 by 100, that gives me 1.12p. Divide both sides by 1.12, so I've got 39.2 divided by 1.12. That's 35%. Over here, we've got A, P, W, so 5 is 5% of what? We're going to divide both sides by 0.05. This should be 100. Yeah, it is. Adding, that should be find the sum. That should be a plus sign between them. I'm sorry about that. So we're actually going to subtract these two because they have different signs. Yes, I know we could use a calculator, but I don't want to. So 6, that's a 1. This is a 5, that's an 11, that's a 9. This is a 3, that's a 1. And it's going to be negative. Now I'm going to use the calculator just because 4.621 minus 3.925. Just double check, and I'm good. Over here, we're going to find the sum, so we're going to add like terms. Or sorry, we're going to add like terms. We're going to add the two fractions. We need a common denominator. That'll be 12, so this become 12. This become 9. These two are opposite signs. We're going to subtract. 9 minus 5 is 4. It stays positive because 9 is bigger over 12. 4/12, though, is 1/3. You still are responsible for those 5 extra problems that I'm not going to do that are on the back of the page. Thanks. Check. Okay, good.